Welcome back. Over the next few lessons and the wider course, we'll be covering storage a lot, and the exam expects you to know the appropriate type of storage to pick for a given situation. So before we move on to the AWS specific storage lessons, I wanted to quickly do a refresher. So let's get started. Let's start by covering some key storage terms. First is direct attached or local attached storage. This is storage, so physical disks, which are connected directly to a device, so a laptop or a server. In the context of EC2, this storage is directly connected to the EC2 hosts, and it's called the instance store. Directly attached storage is generally super fast because it's directly attached to the hardware, but it suffers from a number of problems. If the disk fails, the storage can be lost. If the hardware fails, the storage can be lost. If an EC2 instance moves between hosts, the storage can be lost. The alternative is network attached storage, which is where volumes are created and attached to a device over the network. In on-premises environments, this uses protocols such as iSCSI or Fibre Channel. In AWS, it uses a product called Elastic Block Store, known as EBS. Network storage is generally highly resilient and is separate from the instance hardware, so the storage can survive issues which impact the EC2 host. The next term is ephemeral storage, and this is just temporary storage which doesn't exist long term, storage that you can't rely on to be persistent. And persistent storage is the next point, storage which exists as its own thing. It lives on past the lifetime of the device that it's attached to, in this case EC2 instances. So an example of ephemeral storage, so temporary storage, is the instance store, so the physical storage that's attached to an EC2 host. This is ephemeral storage. You can't rely on it. It's not persistent. An example of persistent storage in AWS is the network attached storage delivered by EBS. Remember that, it's important for the exam. You will get questions testing your knowledge of which types of storage are ephemeral and persistent. Okay, next I want to quickly step through the three main categories of storage available within AWS. The category of storage defines how the storage is presented either to you or to a server, and also what it can be used for. Now the first type is block storage. With block storage you create a volume, for example inside EBS, and the red object on the right is a volume of block storage. And a volume of block storage has a number of addressable blocks, the cubes with the hash symbol. It could be a small number of blocks or a huge number, that depends on the size of the volume, but there's no structure beyond that. Block storage is just a collection of addressable blocks presented either logically as a volume or as a blank physical hard drive. Generally, when you present a unit of block storage to a server, so a physical disk or a volume, on top of this, the operating system creates a file system. So it takes the raw block storage, it creates a file system on top of this, for example, NTFS or ext3 or many other different types of file systems, and then it mounts that, either as the C drive in Windows operating systems or the root volume in Linux. Now, block storage comes in the form of spinning hard disks or SSDs, so physical media that's block storage, or delivered as a logical volume, which is itself backed by different types of physical storage, so hard disks or SSDs. In the physical world, network attached storage systems or storage area network systems provide block storage over the network, and a simple hard disk in a server is an example of physical block storage. The key thing is that block storage has no inbuilt structure, it's just a collection of uniquely addressable blocks. It's up to the operating system to create a file system and then to mount that file system, and that can be used by the operating system. So with block storage in AWS, you can mount a block storage volume, so you can mount an EBS volume, and you can also boot off an EBS volume. So most EC2 instances use an EBS volume as their boot volume, and that's what stores the operating system, that's what's used to boot the instance and start up that operating system. Now next up we've got file storage. And file storage in the on-premises world is provided by a file server. It's provided as a ready-made file system with a structure that's already there. So you can take a file system, you can browse to it, you can create folders, and you can store files on there. You access the files by knowing the folder structure, so traversing that structure, locating the file, and requesting that file. You cannot boot from file storage because the operating system doesn't have low-level access to the storage. Instead of accessing tiny blocks and being able to create your own file system as the OS wants to, with file storage you're given access to a file system normally over the network by another product. So file storage in some cases can be mounted, but it cannot be used for booting. So inside AWS there are a number of file storage or file system style products, and in a lot of cases these can be mounted into the file system of an operating system, but they can't be used to boot. Now lastly, we have object storage, and this is a very abstract system where you just store objects. There is no structure, it's just a flat collection of objects. And an object can be anything, it can have attached metadata, but to retrieve an object, you generally provide a key, and in return for providing the key and requesting to get that object, you're provided with that object's value, which is the data, back in return. And objects can be anything. They can be binary data, they can be images, they can be movies, they can be cat pictures, like the one in the middle here that we've got of Whiskers. They can be any data really that's stored inside an object. The key thing about object storage though is it is just flat storage. It's flat, it doesn't have a structure. You just have a container. In AWS's case it's S3, and inside that S3 bucket you have objects. But the benefits of object storage is that it's super scalable. It can be accessed by thousands or millions of people simultaneously, but it's generally not mountable inside a file system, and it's definitely not bootable. So that's really important that you understand the differences between these three main types of storage. So generally in the on-premises world and in AWS, if you want to utilize storage to boot from, it will be block storage. If you want to utilize high-performance storage inside an operating system, it will also be block storage. If you want to share a file system across multiple different servers or clients, or have them accessed by different services, that can often be file storage. If you want large access to read and write object data at scale, so if you're making a web scale application, you're storing the biggest collection of cat pictures in the world, that is ideal for object storage because it is almost infinitely scalable. Now let's talk about storage performance. There are three terms which you'll see when anyone's referring to storage performance. There's the I/O or block size, the input-output operations per second, pronounced IOPS, and then the throughput, so the amount of data that can be transferred in a given second, generally expressed in megabytes per second. Now these things cannot exist in isolation. You can think of IOPS as the speed at which the engine of a race car runs at, the revolutions per second. You can think of the I/O or block size as the size of the wheels of the race car, and then you can think of the throughput as the end speed of the race car. So the engine of a race car spins at a certain revolutions, maybe you've got some transmission that affect that slightly, but that transmission, that power is delivered to the wheels, and based on their size, that causes you to go at a certain speed. In theory, in isolation, if you increase the size of the wheels or increase the revolutions of the engine, you would go faster. For storage and the analogy I just provided, they're all related to each other. The possible throughput a storage system can achieve is the I/O or the block size multiplied by the IOPS. As we talk about these three performance aspects, keep in mind that a physical storage device, a hard disk or an SSD, isn't the only thing involved in that chain of storage. When you're reading or writing data, it starts with the application, then the operating system, then the storage subsystem, then the transport mechanism to get the data to the disk, the network, or the local storage bus such as SATA, and then the storage interface on the drive itself, and the technology that the drive uses. They are all components of that chain. Any point in that chain can be a limiting factor, and it's the lowest common denominator of that entire chain that controls the final performance. Now, I/O or block size is the size of the blocks of data that you're writing to disk. It's expressed in kilobytes or megabytes, and it can range from pretty small sizes to pretty large sizes. An application can choose to write or read data of any size, and it will either take the block size as a minimum, or that data can be split up over multiple blocks as it's written to disk. If your storage block size is 16 kilobytes and you write 64 kilobytes of data, it will use 4 blocks. Now, IOPS measures the number of I/O operations the storage system can support in a second. So how many reads or writes that a disk or a storage system can accommodate in a second. Using the car analogy, it's the revolutions per second that the engine can generate given its default wheel size. Now, certain media types are better at delivering high IOPS versus other media types, and certain media types are better at delivering high throughput versus other media types. If you use network storage versus local storage, the network can also impact how many IOPS can be delivered. Higher latency between a device that uses network storage and the storage itself can massively impact how many operations you can do in a given second. Now, throughput is the rate of data a storage system can store on a particular piece of storage, either a physical disk or a volume. Generally, this is expressed in megabytes per second, and it's related to the I/O block size and the IOPS, but it could have a limit of its own. If you have a storage system which can store data using 16 kilobyte block sizes, and if it can deliver 100 IOPS at that block size, then it can deliver a throughput of 1.6 megabytes per second. If your application only stores data in 4 kilobyte chunks and the 100 IOPS is a maximum, then that means you can only achieve 400 kilobytes a second of throughput. Achieving the maximum throughput relies on you using the right block size for that storage vendor and then maximizing the number of IOPS that you pump into that storage system. So all of these things are related. If you want to maximize your throughput, you need to use the right block size and then maximize the IOPS. And if either of these three are limited, it can impact the other two. With the example on screen, if you were to change the 16 kilobyte block size to 1 meg, it might seem logical that you can now achieve 100 megabytes per second. So 1 megabyte times 100 IOPS in a second, 100 megabytes a second. But that's not always how it works. A system might have a throughput cap, for example, or as you increase the block size, the IOPS that you can achieve might decrease. As we talk about the different AWS types of storage, you'll become much more familiar with all of these different values and how they relate to each other. So you'll start to understand the maximum IOPS and the maximum throughput levels that the different types of storage in AWS can deliver. And you might face exam questions where you need to answer what type of storage you will pick for a given level of performance demands. So it's really important as we go through the next few lessons that you pay attention to these key levels that I'll highlight. It might be, for example, that a certain type of storage can only achieve 1,000 IOPS or 64,000 IOPS, or it might be that certain types of storage cap at certain levels of throughput, and you need to know those values for the exam so that you can know when to use a certain type of storage. Now, this is a lot of theory, and I'm talking in the abstract, and I'm mindful that I don't want to make this boring, and it probably won't sink in, and you won't start to understand it until we focus on some AWS specifics. So, I am going to end this lesson here. I wanted to give you the foundational understanding, but over the next few lessons, you'll start to be exposed to the different types of storage available in AWS, and you will start to paint a picture of when to pick particular types of storage versus others. So with that being said, that's everything I wanted to cover. I know this has been abstract, but it will be useful if you do the rest of the lessons in this section. I promise you this is going to be really valuable for the exam. So thanks for watching. Go ahead and complete the video, and when you're ready, you can join me in the next.